and welcome to The Explainer. Today, we're going to jump right into a topic that's, well, it's literally everywhere, hiding in plain sight. We're talking about the secret language of numbers, number patterns. Get ready, because we are about to crack some serious codes.
And hey, before we kick things off, I want to give a huge special shout out to all the freshman students in the Bachelor in Secondary Education program at Romblon State University's San Fernando campus. Seriously, this explainer was made just for you. As the next generation of amazing teachers, think of this as your first step in mastering something you'll one day share in your own classrooms. It's awesome to have you here.
All right, everyone. For today, we're all going to be detectives. So, here's our mission briefing. First, we'll sneak into the secret world of patterns. Then, we'll get our pattern-solving toolkit all ready to go. And finally, we'll crack 4 different case files, each one with its own unique code. You ready? Let's do this.
Okay, our investigation starts right here. Now, the secret world of patterns might sound all mysterious, but really, these things are everywhere. They're in nature, in music, and especially in math. They're like the hidden set of rules that bring order to what looks like total chaos. So, your first clue is simple. Just start looking.
So, what even is a number pattern, really? Well, it's just a list of numbers, a sequence, that follows one specific rule. And that rule, that's the whole game. Finding that rule is like cracking the secret code for every puzzle we come across.
And I gotta tell you, this is way more than just a math exercise. So why does this matter so much, especially for you as a future teacher? Because finding patterns is one of the absolute bedrock skills for building logical thinking. When you teach a student to spot a pattern, you're not just teaching math. You're teaching them how to think, how to analyze, and how to find answers. Skills they're going to use for their entire lives.
All right, every detective needs their tools, right? Well, our pattern-solving toolkit has 4 essential gadgets that'll help you solve pretty much any number mystery that comes your way. Let's get our hands on the first one.
Okay, let's open up our first case file. This is probably the most common type of pattern you'll ever find, the arithmetic pattern. Think of this one as your trusty magnifying glass. It helps you see the simple, obvious connections that are right there in front of you.
So what makes a pattern arithmetic? It's when the exact same number is either added or subtracted to get from one number to the next. The key word here is consistency. That change, it never ever varies. It's a constant, predictable step every single time. Let's look at our first piece of evidence. The sequence is 2, 5, 8, 11, 14. Just take a second and look at the jump between each number. What do you see? You go from 2 to 5, and then from 5 to 8, and then from 8 to 11. Are you seeing that constant change? Do you see the rule?
Let's break this down like a real detective. So, to get from 2 to 5, we add 3. But a good detective always verifies their theory, right? So, let's check. Does adding 3 get us from 5 to 8? Yep. And from 8 to 11? Yes, it does. We've confirmed it. The rule is add 3. And just like that, case closed, we cracked our first code.
Okay, your turn to take the lead on this one. Look at this sequence: 30, 25, 20, 15. Your first clue is that the numbers are going down. So what's the specific rule here? I'll give you a second. Got it? The jump from 30 to 25 is minus 5. Let's check our work. 25 minus 5 is 20. 20 minus 5 is 15. Perfect. The rule is subtract 5. See? You're a natural at this.
Time for the next case file, which means it's time for our next tool, the geometric pattern. Now, if arithmetic patterns are like taking steady steps, geometric patterns are like making huge leaps. These things can get dramatic fast.
So a geometric pattern is where you find each number by multiplying or dividing the one before it by the same number. So instead of just adding or subtracting, we're scaling, either scaling up or scaling down. And that's what creates those really big jumps you see.
Let's examine the evidence. We've got 3, 6, 12, 24, 48. Now, as a future teacher, here's a little tip. A lot of students will automatically try to use an arithmetic rule first. They'll see the jump from 3 to 6 is plus 3, but then they check the next jump from 6 to 12. And wait, that's plus 6. The rule isn't addition. So we need another tool. How else can we get from 3 to 6?
So our new hypothesis is multiply by 2. Let's test it. Does 6 times 2 equal 12? Yes. Okay, how about 12 times 2? Is that 24? Yes, it is. The theory holds up. The rule is multiply by 2. Always test your theory all the way through the sequence. It's just good detective work.
All right, you're up again. The evidence is 80, 40, 20, 10. Now the numbers are getting smaller, but not by the same amount, right? 80 to 40 is minus 40, but 40 to 20 is only minus 20. So it's not arithmetic. What else could it be? I'll give you a moment. You got it. We're dividing by 2 each time. 80 divided by 2 is 40. 40 divided by 2 is 20. Awesome work. We just cracked another case.
Okay, now it's time for a trickier case file. This one takes a really sharp eye. Welcome to the world of the growing pattern. This is where the rule itself actually seems to be changing. But don't worry, even that change follows its own predictable pattern.
So what is a growing pattern? It's where the difference between the numbers isn't constant, but that difference itself grows or shrinks in a totally predictable way. We're not just looking for a pattern in the numbers anymore. We're looking for the pattern inside the pattern. It's like finding a clue hidden inside of another clue.
This table here makes this whole idea super clear. Look at the sequence. 1, 2, 4, 7, 11, 16. The jumps aren't the same. But now, look at that third column. To go from 1 to 2, we add 1. From 2 to 4, we add 2. From 4 to 7, we add 3. See it? The amount we're adding is increasing by 1 each time. That's the hidden rule. So to get from 11 to 16, we add 5. So what would the very next step be? Well, we'd have to add 6, right? Which means the next number in the sequence would be 22.
And here we are, at our final case file for the day. This is a type of pattern you've seen your entire life, probably without even realizing it. It's time to investigate the repeating pattern.
A repeating pattern is pretty much exactly what it sounds like. There's a core group, it could be numbers or shapes or letters, and that core sequence just repeats itself over and over and over, like ABC, ABC. The detective's job is just to figure out what that core unit is.
And this is why these patterns are so important. They are the backbone of art, they're the rhythm in music, they're the structure in a flower's petals. When you teach a student to spot a repeating pattern, you're giving them a key to unlock really complex ideas, like symmetry in geometry or rhythm in poetry. It's a seriously foundational concept. So, we've investigated our 4 main types of patterns. But now, it's time to put down the magnifying glass and think about our real mission. It's time to make that shift from being a pattern detective to becoming a pattern teacher.
Here it is, your official detective's checklist. These are the 3 questions you can always ask yourself and one day ask your students. First, look at the difference or ratio between the numbers. That'll help you spot arithmetic or geometric patterns right away. Second, what's the general direction? Is it increasing, decreasing, or repeating? That narrows it down. And finally, pay attention to the position of each number, because as we saw with the growing pattern, sometimes the position is the key to the whole thing. Keep this checklist handy.
Let's wrap up with this really powerful thought from the mathematician William Paul Thurston. He said, mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. And that just captures your mission perfectly, doesn't it? Your goal isn't just to teach rules. It's to guide your students to that aha moment of real understanding, to help them see the logic and, the beauty behind the numbers. And with that, I am officially declaring all of you to be certified pattern detectives. You've learned how to see the hidden codes in number sequences. So now your mission is to go out there and share this knowledge. Help your friends, your classmates, and one day your very own students see the world with the sharp, analytical eyes of a detective.
Hey, if you found this explainer helpful, make sure to check out our class channel. It's called No Problem Only Solution. Go ahead and like, comment, and subscribe. It really helps us make more content just like this for you.
We've got a whole bunch of new explainers planned for the semester, so stay tuned. Thank you so much for joining me today. Now that you have the tools, I guess my final question for you is what other hidden codes in math and in life are you ready to crack?